All right, Godson, let's just start.
Okay.
So what do you think of the assignment so far?
I've only been able to do the discussion forum assignment. Um, well, it's a few things I don't understand, like the aspect where he talked about graphing the functions, the two functions.
Is that for, oh, yeah, for discussion? Okay.
Yeah, for discussion, yeah. But I've not attempted the written and the learning journals as yet.
Okay, welcome Adel or Adele. Let me
What?
just, yeah, I'm welcoming the
Oh,
person that
okay.
just joined. Let me share my
Okay.
screen.
All right.
Okay, so discussion. Now, the discussion is pretty simple and pretty straightforward. It's just that the language they use, I don't know.
Yeah.
It's just pretty crazy, right? So just to confirm, this is the same
Yeah, it is.
assignment, right? They didn't change it. Okay. So it says, consider the equation x squared plus y minus 2 squared equal 1. And then they go on to confuse you
Mhm.
with this part and the relation. The wordage here makes you think that these two things are different things, but it's actually the same thing. Okay. The
Yeah.
relation xy 0, 2, where r is read as has a distance 1 of. So xy has a distance 1 of, or really should be from 0, 2.
Yeah.
Now anything that has a constant distance from a point is where we know it's a circle. Okay.
Yeah.
So this is the Cartesian plane, and this is 0, 2. Then the relation is really just defining a circle about 0, 2
Okay.
with radius. The radius is equal to 1. That's what it says, it has a distance of 1. Okay. For
Yeah.
example, 0, 3 will be here. This is 0, 2. It will have a distance of 1, right?
Yeah.
0, 3 r 0, 2 satisfies this that they're talking about here. This relation could also be read as the point, and now they're going to say it in another way. They're actually saying the same thing over and over and over. So the algebraic way is the same as what they're saying here. It's the same as what they're saying here, right? It's all the same. In other words, xy satisfies this equation, the original equation, if and only if xy are 0, 2. So
Yeah.
they're saying it in 4 different ways. The same thing they're saying in 4 different ways. Then they ask the stupidest question they could ask, that they could think of, right? Does this
Yeah.
equation determine a relation between x and y? Of course it does. You just explained it here. You explained it there.
Mhm. Yeah.
That's the relation. It's describing a circle about the point 0, 2. Okay.
Yeah.
Now here's where it gets a little more tricky. Can the variable x be seen as a function of y? Okay. Now, now we're going to have to separate relation from function. A relation is not a function, but functions are relations, right? Functions are special types of relations. Can the variable x be seen as a
Yeah.
function of y, like x equals g of y? Okay, what's a function? A function is a relation where the domain gives one and only one range, right? Each input
Okay.
is just a fancy word for input. Each input gives one and only one output. And in the
Yeah.
chapter, you're going to read about the vertical line test.
Yeah.
The vertical line test. If we have a function, let me draw a brand new function. The input will be the x values, right? And
Yeah.
the output will be the y values. Now, if I draw a vertical line somewhere, if if the x values give only one y value, then it will touch
It's a
the
function.
function
Yeah.
once,
Once.
right?
Yeah. Yeah.
So in this case here, we could say that
It's a function.
that y is a function of x, right?
Yeah.
Okay. If for some reason this graph goes on to double back on itself like this, okay,
Yeah.
then one input will give more than one output. In this case, we cannot say that y
Y is a function.
is
Yeah.
a function of x. And as soon as you use this notation, g of x, h of x, even capital letters, m of x, oh, what am I doing? M of x. As soon as you use this notation, you are implying that whatever graph this is a function. Okay?
Okay.
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 Now let's go all the way back to our circle. If y, sorry, if x is a function of y, then every input of y will give one x, one output. Okay?
Yeah.
And then in the next question, if y is a function of x, then each input of x will give one output of y. Okay? But for a
Okay.
circle, each input of x, let's input x here, will give two outputs or two results for y, right? Anywhere
Mm.
between here and here, this range, this domain. Same thing with a y. If we use a horizontal line test, each input of y where the circle exists will give two outputs. So no, x cannot be seen as a function of y, and y cannot be expressed as a function of x. Therefore, x equals g of y is an inappropriate statement. Okay?
Okay.
You cannot write it as g of y. This is implying that it's a function. It's not. Similarly, y equals h of x is also inappropriate. It's an inappropriate statement. Okay?
Okay.
Next question. If these, and they put are, but let's put were. Let's change this to were. If these were possible, then what will be the domains of these two functions? Well, they're not possible because we just established they're not functions, but we're going to answer the question anyway. The domain will be this range of values where the circle exists. Okay? Up here where it says x equals to, let's put a big number, 20. The circle does not exist up here, right? So this is not
Yeah, it
part of the
doesn't.
domain. Hi. Be quiet. I'm speaking. Okay, so where does the circle exist? Well, we know the center of the circle is on the
At
y-axis,
0.
where x equals
Yeah.
0. And we know the size of the circle, the radius of the circle is 1. So the circle exists between -1 and +1. Okay, so
Yeah.
this would be the domain of y in terms of x, right? And we know that the domain going this way will be between 0, 1, because this will be 1 away from the center. So it'll be between +1 and +3.
Negative. Oh, yeah, +3.
Okay, and you could write domain in set notation, whatever notation you want. Okay, so we could say the domain of y will be between -1 and +1, right? And then we could say
Yeah.
the domain of x will be between 1 and 3. You could put it in like set notation. You could say x where um, where x is between -1 and +1, right?
Mhm.
I think this is a safer way to answer this question. What would be what are the graphs of these two functions? Okay, there's many ways you could present the graph. You could use the Desmos calculator, plug in the equation and just show them the graph is this circle, or you could describe it. It's a circle between around the point 0, 2. Okay,
Yeah.
the graph of, and this is confusing again. These two functions, there's no functions, right? We established that these are not functions. But anyway, you could still
Yeah.
answer the question. The graph is a circle about the point 0, 2. Are there points of the coordinate axes that relate to 0, 2 by means of r? Well, they answered this questions halfway for you already. They already gave you an example here. 0, 3 is a point on the
Yeah.
y-axis that relates, that obeys the relation, right? The original
Yeah.
relation. There's another point, it will be right here,
Yeah. 0, 1.
0, 1. Okay, so 0, 3, use a different color, 0, 3 and 0, 1 relates blah, blah, blah. Okay,
Yeah.
by means of r. Here, now this is the most difficult part, expressing yourself. It says your discussion should be a minimum of 250 words
Mm.
and no more than, this is the only hard part of this assignment, right? You have
Mm.
to you have to explain and explain
Explain.
and explain and
Yeah.
explain until you get to 250 words. Other than that, it's simple. Okay. Any
Yeah.
any questions so far?
I think it's pretty clear right now because from the way you explained it using the graph,
Yeah.
it made it so easy to follow.
And let's just jump inside of Desmos real quick. Let's go to Desmos and let's just plug it in. X squared plus y minus 2 squared equal 1. So you go to Desmos, you put x, and then for square, you put this little, let me zoom in. For square, you put this little, I think they call it a caret or carré symbol. this. You press Shift and 6 on your keyboard. So you put Shift and 6 to go up. X squared. For those of you who don't know how to type equations in here. Okay. Oh, I forgot the equation already. X squared plus y, sorry, brackets.
Y minus
Y
2
minus 2
to the power of
square
2
that is equal to 1,
to 1. Yeah.
right? So that's how you do it in decimals. You just type it in like that. You know what? I'll copy it and paste it into Telegram. And you see it looks different in Telegram. That's okay. You just copy it just like that in decimals. Okay. You could click on this if you don't like red. Not this. You click on the gear right here. You could change the color if you want. And then whatever screenshot tools you have for your browser, I could just do web capture and take a screenshot. Or you could click on this symbol here, share graph, and this one, export image. Okay.
Okay.
Change it however you like it or whatever, and then you could put it into your math assignment. Okay.
All right.
And yeah, let's just move on to the other assignment now.
Yeah. I think the written assignment.
Uh, Written assignment. Okay. For this assignment, answer the following questions showing all of your work. Let me just copy this. Let me copy into my whiteboard. Okay, for this written assignment, answer the following questions showing all of your work. Find the domain of the function f of x equals, we have a fraction, square root x minus 6 over square root x minus 4. Okay. Find the domain of the function using interval notation. Okay. So the function, we have radicals, right? We have a square root up here, and we have a square root down here. And what we know about square roots, if this bit is negative, then the square root of it is a imaginary number. It's not a real number, right? So we have to keep the bit under here positive, okay? So we know if x minus 6 is less than 0, then f of x fails, right?
Yeah.
You know, if x minus 4 is less than 0, we know the function fails again, right? And we also
Yeah.
know that if a denominator of any fraction is equal to 0, then the result is undefined, right? So
Yeah.
if square root x minus 4, and by extension x minus 4, right? If x minus 4 equals to 0, then we know it fails, right?
Yeah.
The function does not exist in that domain. Let's look at the first one. Let's look at the first one. If x minus 6 is less than 0, the only way this can happen is if x is less than 6, right?
Yeah.
So x cannot be less than 6. X has to be 6 or more according to this one, right? We know
Yeah.
x has to be
6 or more.
greater than or equal to 6, right?
Yeah.
From the second one, we know that x has to be greater than or equal to
Greater
4.
than or equal to 4.
Yeah, x
Yeah.
greater than or equal to 4. From the third one, we know x cannot be 4. 4 minus 4 is 0, right? We know
Mm.
x cannot be 4. Now, if we look at these three together, if x is 6 or more, it's already greater than 4, right? If x is 6 or
Mm.
more, then it's already not equal to 4. This is this is the only one we need to consider. X has to be greater than or equal to 6. Okay? In other words, this condition, let's call it A. Let's call this condition B. And let's call this condition C. A intersect B intersect C is just A. Okay? The only range of values that satisfy all three would be when x is greater than or equal to 6. Do you understand that?
Yeah. Yeah. Yeah.
So we know the domain of this function, x has to be 6 or more. Okay?
Yeah.
And we write it like this. We write x, 6 is included, right? And it goes on and on forever. And
Okay.
we don't use square brackets here, right?
Yeah.
It cannot be infinity either.
Oh, yeah.
So 6 up to infinity exclusive, right?
Mm.
And that's how we write it in interval notation. Include 6 all the way to, but not including infinity, right? That's this question. Okay. Sketch a graph of a piecewise function. Okay, this is completely different. We're no longer looking at this. This is done. Get it out of your brain. Sketch a graph of a piecewise function, write the domain in interval notation. Then they gave a suggestion, go to the Desmos calculator, put in some functions, then choose your own functions and have fun. Okay. So again, we need to familiarize ourselves with Desmos. Let's get rid of that. Now I'm gonna put a link in Telegram where you could read more about piecewise functions. Piecewise function is just like taking pieces of different functions, right? It's just like what it sounds like. So, and they gave an example. They gave an example within the assignment itself. Here we have a piecewise function with two pieces, the red piece and the blue piece, right? Now,
Yeah.
remember, for a relation to be a function, each value of x can only give one value of y, okay? So if we're
Yeah.
drawing a piecewise function and you say, okay, I'm going to use this piece and I'm going to use that piece, this here would be wrong because there are points here where it will fail the vertical line test. You see?
Yeah.
So,
That's true.
so when drawing your piecewise function, you have to limit your ranges, your domain, sorry. So you could go from like -5, let's say to 0, and say like that. And then from 0, 0 to let's say 4, you have, something else. In this case, no matter where you put a vertical line along the domain, it will return only
One
one
output.
one value, right? So don't overlap them. Don't overlap them. And let's jump into Desmos and see how we can make that happen, right? So you jump over to Desmos. Oh, and you know, it's freestyle, so you could put in whatever equation you want. Let's say, let's just use a straight line. Y is equal to 2x plus 4, okay? And let's use -2 to 0. What you do, you use like these curly braces, okay? Use a curly brace, then you could write it in x goes from -2, sorry, x goes from -2, okay? You hit less than, equal 0. And that's how in the Desmos calculator, you limit the domain. You use the curly braces, right? Then we could continue the piecewise. You click where you see this number 2. You could add another function. You could say, uh, let's just use y equal x squared. Sorry, x carry 2, x squared, right? Now we got to be careful here. If I do like, um, let's limit x from 0 to, I don't know, 6. No, that's too much. Let's just say 3, 2. Okay, that's nice. So from 0 to 2, x obeys this. Now, this piecewise function is wrong, and I'll tell you why. When x is 0, it gives 2 values. It gives a value here, 0, 0, and it gives a value here, 0, 4. So what I drew here is not a function, okay?
Okay.
What we have to do is, instead of including 0 here, I could do just that, right? Now it goes, but it doesn't reach 0, right? It has a value for every x input except 0 here, okay?
0.
So in this case, if I use less than here and I use less than equal to, it doesn't overlap, okay? So you gotta be careful with that. I mean, it's a written assignment and students are correcting it, so they might not even notice if you do like this, right? They might not even
Yeah.
notice, but do the correct thing, right? Okay, Zoom is telling me my time is almost up.
Oh,
Um,
wow.
yeah, I think they limit to 40 minutes. Uh, anything else for written assignment? Yeah, so you just get in here, put in 2 or 3 different functions, jump inside Desmos. This thing is just in my way. Jump inside Desmos. You could come in here, color it up, whatever color you want. I did 3. I did one continuing from here, and then I did one off. It doesn't matter. Okay, just play around with Desmos. Choose your own functions and have fun. Boom. All right, this is another question here. I didn't copy this one. The cost in dollars of making X items is blah, blah, blah. Let me copy it real quick. Paste it in here. What? Trying to be quick. Copy, paste. Okay. Given by this function, the fixed cost is determined when zero items are produced. In other words, find C of zero. Okay.
Yeah.
So we say C of zero will be equal to 10 times 0 plus 500. 10 times 0 is 0. C of 0 is 500. This is the fixed cost. Easy peasy, right? What is the cost of making 25 items?
Yeah.
Okay, just plug 25 in there. We find C of 25. C of 25 will be equal to 10 by 25 plus 500. This is 250 plus 500.
750.
Okay, easy peasy. Suppose the maximum cost allowed is 1500. What are the domain and range of the cost function? Okay, first they were giving you how many produced, which is the input. Now they're telling you to find what's the input from the output. Okay,
Yeah.
so we have to find C of X when C of X is 1500. Okay, this is equal to C of X is what, 10 X plus 500. Let's toss the 500 over here. Okay, 1500 minus 500 equals 10x. Okay, let's toss the 10 over there. We got 15 minus 500 divided by 10 equals x. This will be the maximum. Remember, x is items, right?
Yeah.
15, that's a thousand minus
That's
10.
100.
Sorry, 1,000 divided by 10 equals 100. This is the most items we could produce. So we could produce up to 100. So we could produce from 0 to 100 items, right?
Yeah.
And the range is a cost, right? The cost
Yeah.
could be anywhere from 0 up to 1,500. Okay. Now here is where I'm going to tell you. Here's where there will be some confusion and argument and whatever within the assignment, because some people will say, okay, from B, from A, we have a fixed cost of 500. Okay,
Yeah.
meaning the least we're going to spend at the place is 500, and the most we're going to spend at the place is 1,500. Okay, and then 500 relates to 0 items, and 1,500 relates to 100 items.
100.
Okay,
Mhm.
and uh, I believe this is the answer given in the answer sheet or whatever. Okay,
Okay.
fixed cost 500. I mean, in real life, nobody's gonna pay $500 for 0 items, right?
Yeah.
But according to how the question is laid out and whatever, we found that the fixed cost is 500. And I don't know, you gotta look at it from economics point of view. Fixed cost is fixed cost, right? You have a contract and you gotta pay 500 if you make nothing. Okay, even if you make 0
Yeah.
items.
Okay.
Understand that?
So the cost should be anywhere from, going by
Five
this now, the cost should be anywhere from 500
to 1500.
to 1500.
Yeah, the maximum cost allowed is given here in C, 1500. The fixed cost is 500. Okay.
Yeah.
And remember, when zero items are produced, we found it here in A. When zero items are produced, we still have to pay this 500, right?
Yeah.
So this is the bottom of the range, 500, not zero. Okay.
Yeah.
So the bottom of the range is 500. The top of the range is 1500. The bottom of the domain is zero. And if we max out all the spending, we could only make 100. So the top of the domain is 100. Let me write this is zero properly. Okay. And that's it for a written assignment. Then you have learning journal. Learning journals are pretty straightforward. The only
Yeah.
difficult part is this bit, writing 400 words about nothing. Reflect on the concept of a function. I don't know, just do some research and write what a function is and just blah, blah, blah your whole way through this thing. What is the simplest
Yeah.
function you can imagine? A straight line, or maybe even a flat line. I don't know, whatever. In your day to day, is there any occurring fact that can be interpreted? Like there's so many things, like a bank account, um,
Yeah.
stock prices. I don't know, whatever. Is it possible to view a function? If you're looking at a stock chart, you're actually viewing a function, right?
Yeah.
Or the price of foreign exchange or index or any graph that goes sideways that does not double back on itself. You're viewing a function, right? What
Yeah.
strategy are you using to get the graph? What strategy are you using to get the graph of a function? Well, this will depend on the students and their past experience drawing graphs or whatever. You could say one strategy is to use technology. This is a strategy here, right?
Yeah.
This is a strategy to get a graph. Another strategy is to like remember what curves look like. Curves look like this: square, x cube. Remember what lines look like. Remember what negative gradients look like going down. I don't know. Whatever your strategies are for picturing and drawing graphs. I don't
Mm.
know. Let me just jump back into my this was my learning journal. Let me see what I wrote. I can't even remember. I don't know. The question is kind of stupid, right?
Yeah.
Whatever. Okay, so what I did, I took all the questions they asked, I made them into headings. Okay,
Okay.
so where is it? Let me just copy. So we have a whole bunch of questions.